Welcome back all of you to another session of virtual classes from Science. I am Shabu Subramanian here with more problems of relative velocity which are related to the crash program of physics. Okay, so here we have a question. There are six particles at the corners of a regular hexagon of side A moves at constant speed v. Each particle maintains a direction towards the particle at the next corner. Calculate the time the particles will take to meet each other. It's a regular hexagon problem. Looks to be a two-dimensional problem, but we will see that this is an example of one-dimensional problem. And the options which are given are 2a by 3v as A, B option is v by A, C option is 2a by v, and option D is a by 3v. So let's start with the problem by drawing a regular hexagon. So here is the problem. We are having say 6 particles at all the corners, each are moving with the velocity of say v, and the side length is equal to a. Problem is, say the first particle will be moving, say this is, I am calling this one as capital A particle and this as capital B particle. A is moving towards B and B is moving towards C. This is the situation. We are having this one as velocity V and this one as velocity V itself. Problem is to get when the particles will meet. This will become very easy for you if you can reduce this one into the case of arresting. Okay. Now I am taking the B is arrested. Okay. So let us take the situation in a different manner. I am assuming that A's relative velocity, if I am taking this one as VAB, A's relative velocity with respect to B, VAB, we know that is equal to VA minus VB. So if A is supposed to be moving with VAB, and if B is at rest, that means VB is equal to 0, then what is the distance to be covered? Distance to be covered is nothing but A. The problem is how to find the time taken. So time taken will be simply equal to distance that will be covered divided by velocity of A with respect to B. Velocity of A with respect to B in that direction. That is what we need to find. Okay. So we are going to continue with this. Okay. So here we have assumed that B is at rest. Okay. And we have to get VAB. VAB in which direction? In this direction. Okay. We know VA is in this direction. This is the actual direction of VB, but I have to get the component of VB in this direction. So as to get the relative velocity, I have to find the component of VB in this direction. What about this angle? This angle will be 60 degree. For regular hexagon, you know that all the angles will be equal to 60 degree. So what will be the value of VB onto that? That will be equal to VB cos 60. Because if I plot, this is an adjacent side. Okay. So in that line, what is the relative velocity? Because that is the line in which the displacement is taking place. So VAB for this is equal to VA minus VB cos 60. VA is, we have given it as V itself. VB is also V and cos 60 is 1 by 2. V minus V by 2 is V by 2. We got the value of VAB. Substituting into that, the time taken is equal to what? A divided by V by 2. That is equal to 2A divided by V. Which is the option? Option is C. So we can see that this problem can be reduced into a one-dimensional problem. This is a very interesting question, okay, because elevator or lift problems are very common when we study Newton's laws of motion, in which fictitious forces like pseudo forces are acting and all. We We'll study the case of lift moving up as well as lift moving down. You must be remembering how the acceleration due to gravity is changing. Okay. So this is a problem not related to that. This is a problem related to the relative velocity. Okay. Here an elevator car or a lift whose floor to ceiling distance is equal to 2.7 meter. That means the lift height, total height is 2.7 meter. Starts ascending with constant acceleration 1.2 meter per second square. 2 seconds after the starting, a bolt begins to fall from ceiling of the car. Find free fall time of the bolt. You have to find the free fall time of the bolt, and what is given is a lift is moving in the upward direction. Okay, so you have to find the net acceleration due to gravity of that. Given g is equal to 9.8 meter per second square. Options A is root of 0.54 second. Option B is root 6 second. Option C is 0.7 second. And option D is 1 second. Let us analyze this question. What is given over here? We have a lift car or an elevator car. So maybe it is connected by a cable to the height. And this is given that it is ascending in the upward direction. A. Lift moving up, the net acceleration or the resultant acceleration is g plus a. The net acceleration due to gravity is g plus a. When the case of lift is moving up, that we will see in the case of Newton's laws of motion. Okay. When it is moving down, it is always easy to remember moving down, it is g minus a. That is why when it is freely falling, there will be weightless condition, g minus g, that will be equal to 0. So upward, always remember that up means the net acceleration of the lift is equal to g plus a. Whichever be the particle which is inside, that also will have the same acceleration, or that will also feel the same acceleration. So what is given in the problem? A bolt from this point starts falling down after how many seconds? After its time of 2 seconds. After the start of the lift. Now what is the time taken by this bolt to fall to this height? What is that height which is given as? 2.7 meter. That's a height. Problem is to find the free fall time. Okay. So now I can draw an equivalent diagram for this, in which I can consider that the lift is at rest. The lift is at rest. That means earlier there was an acceleration, lift is at rest. Now the bolt is falling down with an acceleration due to gravity which is equal to g plus a. So there is a free fall problem, it is falling through g plus a. Your problem is to get the time of fall. We know the height or the displacement that should happen for that. We have to find the time taken. This is the way. You know that it is free fall, so initial velocity is equal to 0. We have got initial velocity, we have got acceleration, we have got the displacement, we need to find the time taken. Substitute. What is S is equal to? ut plus half a t square. S is h, ut is 0 plus half g plus a t square. We need to get the t value. Substitute. T square is equal to, say, 2h divided by g plus a. What is 2h? 2h is 2 into 2.7. 9.8 plus a is 1.2. This is, say, 5.4 divided by 11. T is equal to root of 5.4 divided by 11. 5.4 divided by 11. The value is equal to 0.7 seconds. So the answer is C. Here we go with the next question. Again a train problem. A train of length 200 meter moving towards south at 20 meter per second. A bird flying with 5 meter per second towards north. What's the time taken by the bird to cross? The length of the train. Options which are given as 10 meter per second, 8 meter per second, 40 meter per second and 20 meter per second. A regular problem in all kind of reference materials we can say. Problem is like we have a train of length 200 meter and the train is moving towards say south with the velocity of 20 meter per second and the bird is flying with velocity say 5 meter per second. We need to find what the time taken by the bird to cross the train. We'll take the relative velocity of bird with respect to train. Then what we can assume? The train is at rest. So Vt is equal to 0. Distance to be covered is 200 meter. We haven't got the distance. We got the relative velocity. Problem is what's the time taken? They are moving in the opposite direction. What is the relative velocity? We know that it is Vb plus Vt. Simple problem. Because we are seeing opposite directions, the velocities gets added. So 5 plus 20, that will be 25 meter per second. You got distance, you got the velocity. Now it's your time to find the time taken. 200 divided by 25. What will be the answer? That is 8 meter per second. Problem is very simple. A conceptual question to check the knowledge of yours based on relative velocity, how much you are efficient to do the problems related to relative velocity. The problem is given like the distance between two particles decreases at a rate of 6 meter per second. Now, if these particles travel with same initial speeds and same directions, then separation increases at 4 meter per second. Problem is the particles have speeds as option A 5 meter per second, 1 meter per second, option B 4 meter per second, 1 meter per second, option C 4 meter per second, 2 meter per second, option D 5 meter per second and 2 meter per second. First of all, you have to understand the the problem very clearly. First, what is given? The distance between two particles decreases at a rate of 6 meter per second. That means they are coming closer in a particular situation. Now, second situation is if they travel with same initial speed and the same direction, then separation increases at 4 meter per second. So that situation we can analyze first. If they are moving in the same direction, separation increases at 4 meter per second. That means the distance is increasing at 4 meter per second. Oh, what does it indicate? That indicates if A and B are the particles, relative velocity of A with respect to B, because distance is keeping on increasing at a rate, that means the velocity itself. Same direction, the relative velocity is Va minus Vp, that is equal to 4 meter per second. I think that is the way to start with. We have got same direction, Va minus Vp, which is equal to 4 meter per second. Now in the first equation, what is given? Distance decreases at a rate of 6 meter per second. Distance to decrease, what should happen? They should travel in the opposite direction. Opposite direction, what is the relative velocity? That is Va plus Vb. That is 6 meter per second. You got Va plus Vb as 6 and Va minus Vb as 4. Same direction, definitely if one velocity is greater than the other, the distance will keep on increasing. Opposite direction, definitely the distance will decrease. So that concept, that idea we should have. What is the possibility? For this to happen, only this is the possibility after the options. Or you can add and check the values. 2 Va will be equal to 10, then you can substitute and get the answer. So the answer is 5 meter per second and 1 meter per second. Here we are with a problem which will clearly identify or clearly make us to understand the difference between effective velocity and relative velocity. Effective velocity and relative velocity. So just keep that in your mind. We are going to see what is the difference between effective velocity and relative velocity? Problem is, a police jeep is chasing with velocity of 45 km per hour. A thief in another jeep moving with velocity of 153 km per hour. Very high speed when compared to the police jeep. Maybe police jeep must have just started and started chasing, and thief must have been achieved that speed. Now, police fires a bullet with muzzle velocity say 180 meter per second. The speed of the bullet is called as muzzle speed. The velocity with which it strikes the thief is, question is, with what velocity that will strike the thief? Options are A 150 meter per second, B 27 meter per second, C 450 meter per second, and D 250 meter per second. This is what we have given with. Now we have to see what is the difference between effective value of velocity and the relative velocity. Okay, so we are going. So first one is a column for effective velocity, because most of the students will get confused with this kind of concepts, because I have already given that relative velocity when two particles are moving in the same directions have to be taken as a difference. Now first, imagine we do have a jeep which is a jeep of police, and this is the jeep of thief. And what is happening? Within the jeep of police there is a gun from which a bullet is fired. So the gun is within the police jeep. So what the gun also should have? The gun will automatically have the velocity of the police jeep. We can say that is the inbuilt or default velocity of the gun, because it is carried by the police jeep. So what will be the velocity of the bullet, or we can call effective velocity of bullet when it is fired? That will be, we can say, velocity of the bullet will be equal to what? Muzzle velocity of the bullet, that is the normal velocity which the bullet gains when it is coming out of the gun, plus velocity of the police jeep. That is the effective velocity. That means bullet will have a velocity which is greater than its muzzle speed, because it is already in a frame which is moving, or it is in a frame which is already moving. So I can put muzzle speed of the velocity is equal to 180 meter per second, and police jeep is 45 kilometer per hour. We can convert that one into meter per second. Substituting, we will get 192.5 meter per second. This is the value. Now next question is, with what velocity it strikes the thief? For that we have to take a relative velocity concept. Now what we have? We have a thief who is moving at a speed of, say, Vt is equal to 153 km per hour, which is equal to, say, 42.5 meter per second. A bullet is coming with a velocity of, we have 192.5 meter per second. With what speed it will strike that? What I can consider, I'll take the thief is at rest over here, so Vt is equal to 0, and the bullet is coming with a velocity which is a relative velocity of the bullet with respect to the thief. The problem is simple, both are moving in the same direction. I can find Vbt. What is that? Vb minus Vt, which is equal to 192.5 minus 42.5. What is that? That is nothing but 150 meter per second. So we have seen the difference. See, in all the cases, whenever you see as the same direction, don't take the difference, because check whether it is a case of effective velocity, or whether it is adding the velocity to that, or whether you have to consider two situations or two bodies. So that is the difference between effective velocity and relative velocity. I hope the session must have been useful for you. because you have seen different varieties of problems of relative velocity in one dimension. So for any doubts, just put that one as your comments in the comment box below the video, and just shoot any problems which you find it necessary or doubtful to be done. You can send that one as a comment to me, then I will try to solve that one in the next video and I will send it to you. So thank you very much. This is Shabu Subramanian signing off from the virtual classes of Science here. Thank you all.